In this video, we'll discuss how to identify and distinguish between the different carbonyl containing functional groups. So whenever you hear carbonyl, that indicates exactly how two specific atoms are bonded. It indicates that we have a carbon double bonded to an oxygen. So this represents the carbonyl. But we already know that carbon wants 4 bonds. So we know that there are 2 other bonds attached to that carbon. What bonds are attached to the carbon will distinguish and allow us to identify the different functional groups. And so if one of those bonds from the carbonyl goes to a hydrogen, then that represents an aldehyde. Aldehyde has the H in the name. There's an H representing your hydrogen bonded to the carbon of the carbonyl. The other we can just call R. It can be a single carbon. It can be a chain of carbon atoms, a ring of carbon atoms. It can even be an aromatic ring. But in some cases, you'll have molecules that have 2 carbon groups. They can be 2 of the same carbon groups. They can be different carbon groups. So I'll just designate one as R prime. That R prime and R could represent the same thing or different things. But whenever the carbon of the carbonyl is bonded to 2 carbon atoms or 2 carbon groups, it represents a ketone. And then the others will have heteroatoms present. So we still have this same portion of the molecule, but again we're looking at what's bonded to the carbon of the carbonyl in order to distinguish one group from another. Next group we're going to look at, we have a hydroxyl, so that OH group bonded to the carbon of the carbonyl. When there's an OH group bonded to the carbon of the carbonyl, it no longer represents an alcohol. So we've seen the OH with alcohols, but when the OH is bonded to the carbonyl carbon, it becomes a carboxylic acid. Although these atoms may have, or molecules may have some of the same properties as alcohols, they are not identical to an alcohol. All of their properties will not be the same as alcohols. And definitely the names will be different from those of alcohols. And then the next one, again we can look at the heteroatom. So we can also look at another oxygen, but instead of that oxygen having a hydrogen bonded to it, it may have another carbon group. Again, it can be a single carbon atom, it can be a chain of carbon atoms, it can be a ring of carbon atoms, it can be an aromatic. But whenever you have the oxygen that has carbon atoms bonded, it now represents an ester. And then the last molecule, again thinking about the heteroatoms, and recall heteroatoms are just any atom besides carbon and hydrogen. But now, what happens if we have a nitrogen bonded? So I'm going to just show it as nitrogen. We know that when we've dealt with amines, there are different types of amines, primary, secondary, tertiary, and they differ in the number of carbon or hydrogen atoms that are present. The same thing applies with this. We can have 2 carbon atoms, we can have 1 carbon and 1 hydrogen, or we can have 2 hydrogen. But what identifies this next group, which is known as an amide or an amide, is when you have the nitrogen directly bonded to the carbon of a carbonyl. So these are your different carbonyl containing functional groups. And again, what you are looking for in order to distinguish one from another is the group or the single atom that I have shown highlighted in the pink. This is what determines and classifies the different type or classes of carbonyl containing functional groups.